Thank you all for coming on behalf of the Farrar Utility District today. This is a warm meeting, except the commissioners are in the audience. We're not conducting any business other than sharing with you the work of the UVM students and program on the looking at the resources and things in our waterworks that were so important to us for use of the water supply. And we also hope to use this information in developing our plans for recreation and things to the degree that we can protect the water supply and things. So with that, Sophie Manowitz is going to show you the program and introduce it, and there's questions and things at the end that they can answer. So with that, thank you for coming, and it's your show.
Great, thanks so much, Skip. Good morning, all. So happy to be here. I have the distinct pleasure of introducing this project, but really a portion of our team of graduate students is about to take it away, and we'll be spending most of the next 2 hours sharing their findings about the Waterworks parcel with you through a series of different themes. We'd originally envisioned splitting our time between a presentation and a field walk, but you're probably all happy to know that we're not going to take you on a field walk on this rainy Wednesday morning. So it looks like it's perfect conditions to be indoors, although I'm sure that there would be lots to discover about the flow of water across the Waterworks landscape this morning. So for those of you who aren't familiar, we know that some of you in the room have been deeply involved with this project from its outset, and maybe some of you are dropping in to hear about it for the very first time. The group that's here is a team of graduate students who took part in a service learning course in the University of Vermont Field Naturalist program this semester. And each spring, our Field Naturalist graduate program sets out to find a community sponsor, someone who owns a large parcel of land, where our team can learn the basics of conducting a natural resource inventory and landscape assessment. And I just said learn the basics, but really what this means is they're taking a deep dive and trying to understand the pieces and patterns and processes on that land, from the bedrock up to the wildlife communities, the birds, the mammals, and everything in between. And their goal is to integrate all of those pieces into a story and a set of informed management recommendations to meet the needs and questions of the sponsor that we're working with. So we were delighted to find this parcel of land. Those of you who have been up there know it's a beautiful place. It's an interesting and diverse landscape from a natural resources perspective. And we're going to dive into some of those stories and scenes over the course of our time here this morning. So I do want to start off by saying a few thank yous, though. We have Walter Pullman, our program director, in the room, who is instrumental in connecting us with this project. I want to say a big thank you to Bill Woodruff and to Skip and all of the EFED commissioners for also guiding us in this process and being such a resource, as well as the Waterbury Conservation Commission and Josh Lincoln in particular, who really was like the 13th student in our program, joining us on all of our field trips and helping to connect us to this landscape to conduct this project. So, my slide did not advance here. Interesting. It advanced on my screen, it just didn't advance on this screen, right? The best laid plans. Let's see what's going on. We jinxed ourselves by saying all of the A/B issues have been solved at the outset of this program here, and it might take somebody who's more familiar with this system and our screen sharing to know what's going on. Huh.
Get them.
I wonder if we just try pulling out the HDMI cord. Apparently, so the HDMI cord is in there.
Oh, was it changing,
yeah.
right? Or no?
Well, it was changing on here, and I didn't realize it wasn't going to change on there.
Escape.
Yeah.
Let's see. I like yours.
Right there.
Yeah. Let's see how this works.
And there's I don't think there's changing things on this end. No.
Yeah.
It's a mystery. Would it be in the Zoom settings maybe? Here's the important thing. If you switch to your story map, does it show up on the screen? Okay, let's no. Okay, here. Let's just change the screen sharing option.
Yeah, it's probably in the display settings.
Same screen instead of application. We can start with there. I had it on screen before. It's still not. So try application. It's so strange.
I think the Zoom is the thing that's frozen. Like, you're in the top left. And
Thank you. Yeah. Yeah. So Zoom is frozen. Okay. Do you want to be a network screen? It could be a network. Okay.
Oh, okay.
Okay. Okay. Well, so our concern now is we can run this presentation for the room, but it looks like it's not being recorded on Zoom. That's
Action on that screen.
While we're starting out, so we've discovered Zoom is frozen, and so we're going to consider the merits of being able to recapture it for those who are listening in from home or who are hoping to access this recording later. We do have a computer that's ready to roll to be able to offer this presentation in the room, so do trust that you're about to hear this information today. We're just going to see if we can troubleshoot for those who are hoping to watch this in the future. And just to set some expectations, each of our 4 student groups is going to be presenting for about 15 minutes. And then we'll have 5 minutes for questions about their particular topic. And then we've saved time for about 30 minutes of additional questions and discussion at the end of this program as well. Feel free to access some bagels and cream cheese if you're looking for a snack through the morning. And do feel free, if you find any of the visuals are on the smaller side, to move yourself up towards the closer end of the room so that you have the best chance to view some of the details on the maps here. Once we get this underway, you'll see that most of the visuals are going to be shared in the form of something called a story map. And if you're not familiar with that format, it's a platform, a web page essentially, that integrates photos and videos and maps and text. And so if there's anything that you can't see sufficiently on the screen today, know that we are going to be providing a link to that website resource where you'll be able to scroll through and read the story.
This meeting is being recorded.
Access all of the information that's shared there in the future as well. So here's a first taste and orientation that you'll see today. Are we in business?
We are now.
Well, I heard my cue, bagel.
I recommend for this moment, so you can proceed,
Let's just launch in.
launch in that way.
We'll have to figure out a public or a Zoom recorded one later.
And we can pause and pick it up.
All right. Apologies to, are folks on Zoom actively trying to listen in? Hey, look at that, it gets bigger too. There, hey, there's the second picture. All right, thanks all for your patience. This is my least favorite thing in the world, right? Wading through slideshow issues. But here we are in the field. What you can't see in this image, I just wanted to walk you through a few images of the semester and introduce you to our team of 12 students. So 6 of them are graduate students in the Field Naturalist program, and then 6 of them are graduates, PhD and master's students in the Natural Resources School or plant biology department at UVM. And so I said that this opportunity was, a way for them to learn how to conduct a landscape assessment, but they brought in so much skill and past experience and expertise that they were building on. We started off the winter, or the start of our winter, looking at animal trails across the snow. So I don't think it's showing up on this screen, but there's a beautiful trotting red fox trail that cuts through this image here. And we were tracking animals across the landscape and setting up game cameras to capture wildlife footage, which you will be treated to some of at the end of this talk. We drew on many local experts and friends of the Field Naturalist program to share their expertise and inform our explorations of this parcel. So big thanks to Sam Ford, who's in the room today. You can't quite see her face here, but she is handing a hand-thrown brick up to one of our students as we were exploring some of the cellar holes on the Waterworks site. Bob Zano from Vermont Fish and Wildlife, who's also a graduate of our program, went on a walk exploring the different natural communities on site. And so here we're looking at an area of wet ground, a seep in the middle of the forest. Stephen Wright shared his geology expertise on an afternoon exploration of bedrock and some of the glacial history that really drives the flow of water across the landscape. And then here's Steve Hagenbu showing us some bird habitat assessment techniques and ways to look at forest structure, so the different sizes of trees present on the landscape and other features that provide bird habitat. So we had a very full first 6, 7, 8 weeks of the semester, getting out into the field and just getting to know this place, and then the students were set loose in field teams to conduct research that they'll be sharing with you in just a few moments. And you're going to see this divided up into 4 different subject areas. So starting with the human history on the land, we have a red pine plantation with an apple tree in the foreground, standing in to show a couple of the human-influenced features on site. And then you'll hear from the Enduring Features team. So this is a team that looked at topography and geology and soil and water. And then we'll look to plants, forest health, and natural communities. The extensive amount of field work that went into that. And then end on the topic of wildlife and get to consider both who's on site and how this site forms part of a bigger landscape of connected wildlife habitat. And so, since wildlife is my specialty, I just wanted to share a couple of scenes, and these are just examples of some of the pieces, some of the discoveries that this project was based on. And I knew that we'd found a special site for our project at the outset because we found some really incredible wildlife sign right on our very first field walk with Woody across the parcel. On the left-hand side there, what looks like this fuzzy gray, hard to describe object is a pellet from a great horned owl. So it's over 3 inches long, coughed up by an owl that was probably perched high in the branch of a white pine tree overlooking one of the beaver ponds. And we found this weathered pile of fur and bones at the base of that tree. And then on the right-hand side is a red pine tree that's been bitten and clawed by black bears to the point that there's a big wound on its side, and there's all these horizontally oriented bite marks and scratchings from bears that have been coming every spring and summer to rub their backs, do a little dance, and deposit their scent on that tree bark. And just on my most recent exploration around the parcel, I just had to share my favorite finding of the whole semester. This is a mossy game trail, right, wildlife pathway. And in the midst of that moss, there are a couple of worn, big oval patches, bigger than a human footprint. And this is a ritual trail or stomp trail of a black bear. So where male black bears during their spring scent marking and mating season into the summer have been coming through year after year and stomping their feet into the ground, twisting the pads of their feet until the moss has totally worn away in those locations. And they come and do this with a stiff-legged gait over and over again in the exact same spots year after year. And so you can see the black bear use of this landscape, the activity written into the ground or into the moss, and with some associated bite marks and toppled saplings as well. So The Waterworks is a very special place, and we're excited to dive into all of its stories today. So I'm going to turn it over to our student team who will be sharing their story map, and I think we'll start with Annie on the human history team.
You're muted for it because I turned off the computer sound because it was. Oh, okay. That's fine.
Where did it all go?
This is starting to get comical.
Someone has to succeed.
There's other projectors out of it.
How did we lose that?
Makes no sense.
This isn't plugged in.
That's a power cable. This connects to the projector. Would you just check that?
What did we switch from or to?
We just switched to like a browser instead of the PowerPoint, which shouldn't have affected
That
this.
should not have affected that. And yet.
It's so strange. Okay, watch it.
No.
Did you try getting out of the screen share back in? I don't know how to do anything.
Really, it's a hardware thing.
Yeah.
It's completely inexplicable.
Are you still signed into the Zoom account?
It
If you're
looks,
screen sharing, you
it says your screen share.
Yeah, because Zoom keeps on popping up messages onto the screen.
yeah,
Should I, let me
back out.
stop sharing?
Yeah, and back out as a
And then let's try again. Let's share just this.
because that is not working at present.
It's saying that the screen that is up yeah, she wants everything to be what it is. Another option is
Do we have another HDMI cable?
I don't know what
Again.
absolutely nothing changed.
It seems like it's the
Let me ask I said there were no issues, and then it happened.
My neighbor
We did that a couple times.
But I don't know.
Put on it to try and put onto the computer that works.
Oh.
There we go. Thank you, Josh.
You guys don't need to see all of my tabs. Just one chart.
Let's shut this, and then this is not going to work anymore, so I'm going to turn it off.
How much battery do I have? I'm full. Let me know if anything happens.
I bet you'll know. Yeah. All right. Okay. Thank you, everyone, for bearing with us. Sorry about that. So yeah, we're going to be presenting our research that we've been doing this semester, and we're going to start with a bit of the human history and land use of the parcel. So I'm just going to give you a bit of a background on our research methods. So as we know, this land is the ancestral land of the Abenaki, and they likely stewarded this land in ways that we're not aware of. But what we had access to were written records post-colonization. So that is what we focused on for our research. And for our methods, we went to a couple of different sites. We visited the Stowe Town Clerk and looked through land deeds on the parcel, who was transferring land to whom, what they were doing on that parcel. Then we went to the UVM Special Collections and we looked through their microfilm records of the agricultural census to find some of those names that we had from the land deeds. So we looked up what people were farming on the parcel. And then we also browsed through digitized historic newspaper collections, historic maps, historic photos. And then we worked with research specialist Sam Ford, who helped us with this whole process and also did a site visit to look at foundations on the site. So a bit of background on the early residents. So this is a plan of Stowe, the original sort of lotting plan. This map is from 1913. But you can see sort of all of these lots are a variety of different sizes. Our parcel is down here in this corner. And these are the original proprietors of the land listed on the side here. So this was an important reference map for us. Here's sort of a zoomed in photo of where our parcel is. And the town of Stowe was chartered in 1763, divided into parcels. And this land changed hands a lot over time. So that's what we dug into at the Stowe Town Clerk. And you'll see in the bottom corner, there are two lots here that have words in them. These are called glebe lots. So some of you may know this, but this is sort of a land system that was carried over from Europe, where essentially there were these parcels of land that were set aside, and the rental income from those pieces of land was used to pay for services like schools, religious work, or other community needs. So here we have a school glebe lot, and then just the edge of the parcel touches this lot for the Propagation Society, which I believe was a religious organization. So that's just kind of an interesting tidbit of history there. So we went to the Stowe Town Clerk. We dug into some land deeds. They looked like this. They're a bit hard to read. We were very fortunate to have Sam with us the first time we went, so she really helped us decipher some of this. But we learned quite a bit from these land deeds. We sort of used them to track purchases, sales, and leases of land on these lots in the 1800s. So we learned the sizes of the parcel, past land use. There are references to lumber, mills, sugaring, dairy cows, horses, and sheep, among other things. And then there are also some references to forms of payment. And this particular deed is kind of interesting. This is from O.C. Clough. He traded his land to George W. Brown in exchange for a horse. And it says in this deed that if the mare wasn't good enough, the deed would be void. So there's some sort of interesting little interactions that were happening with this land. It wasn't just being traded for money. There were some other communications happening. And then towards the end of the 1800s, there was some information in these deeds about the town of Waterbury and water infrastructure being set up on the site. So there's some references in 1896 to Waterbury diverting water from the brook for use for the village, constructing a dam, and laying an aqueduct on Horace Merriam's land. So that was helpful to browse through that as well. And then they also just mentioned the existence of roads, so we were able to sort of track those over time as well. So for our next step, we went to the University of Vermont Special Collections, and on microfilm, they have records of the agricultural census. So this is just half of what an ag census page looks like. You can't see super well on the screen, but over here are the names of the farmers, and then across the top is sort of livestock and crops that they might have grown, so you can see what they had going on their farm. So we used names that we got from those land deeds to look in these records from Stowe. We looked up those familiar names to see who was growing what or farming what on this land. And these records were between 1850 and 1880. So they showed a pretty consistent land use between the different parcels. Common crops included wheat, corn, hay, rye, oats, peas, beans, potatoes, grass seed, barley, buckwheat, and maple sugar. And they were also harvesting timber on the land. And then livestock included pigs, oxen, sheep, milking cows, horses, cattle, and poultry. And then those animal products they got included butter, cheese, wool, and leather. So they're doing a lot on this land. And then after this, we sort of also cross-referenced with historic newspapers that we had access to, and that confirmed a lot of the information that we found in here about farming. But they also had some extra things. I talked a little bit about the copper ore that was found on Isaac Merriam's farm, and then Cooley and Prescott building a 40-horsepower engine on their land for sawing shingle. So there's some unique activities happening here as well. And then these are some of the historic maps that we referenced. So this is an 1859 map. You can see the ephod boundary over here. This is Merriam's farm. A sawmill is up here. And then this is from the 1870s. Cooley and Prescott are over here, again with a sawmill. So that was kind of helpful to just give us some reference as to what was where, who was on the land, even though it doesn't specify necessarily everybody who was there. So our next step was to look for remaining structures on the land. And again, we worked with Sam Ford, looked at some of these LiDAR maps. And on LiDAR maps, typically if you see structures that are really square, they have straight lines, those are human-constructed things. They don't look quite natural. So here you can see we have a couple of different foundations or cellar holes. And then this, you can see this really straight line is a stone wall. So we went onto the site to sort of locate where these were in person. I've got some pictures of that. It's a bit hard to see because there was snow over everything, but you can sort of see this is the corner of one of those cellar holes. So this is the remains of a cellar, potentially from an English-style house in the late 1800s or early 1900s, and it's made out of stacked stones. Again, difficult to see. If you go there now, this is right by the parking lot. So you can see probably better now without the snow. This structure was in a nearby brook, sort of close to that foundation. It's a square structure made of cement, which indicates it's probably a lot newer, might have been part of some water infrastructure that was there at some point. This is the main waterworks road, and you can see it's really sort of sunken into the ground. I'm sure you're all familiar with this, but it's kind of cool. This road has been used for hundreds of years and maybe looks similar to what it did for the farmers that lived there.
Recording in progress.
Amazing. So this is another cellar hole, that second one. So this is made of smaller stones. It is likely somewhat older than the first one, maybe mid-1800s. And we believe that this was Isaac Merriam's home, where he lived with his family of 11 children, which is a lot of children to fit in one very small house. And we'll talk more about the Merriams later. They're sort of recurring characters in this story. This is one of the stone walls on the site that you saw in that LiDAR image. So this wall was pretty extensive. I'm sure there are others around, but this might have been to contain livestock. And we got another clue to that. There was some wire along this fence, and some of that wire did not have barbs, which indicates that they were probably sheep kept in there. A lot of times sheep wire didn't have barbs because it would get caught on their wool. Farmers didn't want that, so this is indicating that there were probably sheep in that pasture. And then this is sort of the largest and last foundation that we looked at. This is made of much larger stones, potentially dating to around the 1860s, mid-1800s, and we're not sure of the exact use of this structure, but this one was very apparent. This is sort of a close-up of those foundation walls. And then we also found quite a bit of debris in or near the stream. So this might have been, we're not sure exactly what it is, maybe some sort of water infrastructure, maybe something else, but there's sort of a lot of stuff in these bigger streams just along the banks. Some of those things were old bricks, so a lot of times they would reuse old bricks for new structures, so we found some of those near the foundations and also near the streams. And then there was also quite a lot of old discarded equipment, bottles, farm equipment, metal receptacles, ceramics, a lot of different stuff in sort of like these midden piles close to those cellar holes. And so some of that, is scattered across the landscape, potentially getting into some of those streams as well. So we read part of this book called History of Waterbury from Ward Knapp, and I'm going to read you just one of these quotes. This is an image of the Merriam family, who we've been talking about. You can see a little bit back here, this is Horace Merriam, and his family, his wife is over here. So one of the quotes from this book talks about the author's wife's family history, and he said, "The farm was the Merriam farm, where my wife Eva grew up. Eva's father built a large hen house and raised 200 Rhode Island Reds. We had an egg route in Waterbury, and the money from the eggs was used to send Eva's sister to college," which is pretty cool. And again, we'll share this presentation with you, so if you want to go back and read the other quotes that we pulled, you are welcome to do so. All right, so as you know, the parcel was transferred to the village of Waterbury in 1895, and local newspapers reported that a water supply for the village of Waterbury for domestic use, fire protection, or any other purpose that may be necessary. This is some current water infrastructure on the site. So the land was purchased from Charles Stevens, Horace Merriam, John Gibbs, and A.E. Gibbs, and the Gibbs Spring specifically was mentioned as one of the finest springs in the area. And then in January of 1896, there was a letter we found in special collections that was sort of soliciting contractors to come and lay water pipes, furnish valves and hydrants, and sort of building these reservoirs on the site. And by September of that year, it was reported that Waterbury can now boast one of the best water systems in the state, pure mountain spring water, and an abundance of it constitutes the new waterworks. So they're very proud of this at the time. Still are, I'm sure. So we were able to look at some aerial imagery as well that sort of shows land use change over time. So this was 1979 is on this side, and then in 1996, and you can sort of see it changes. There's some of these. Oh, mouse isn't working, but. Over on this side, if it let me go over here, there's some sort of human-constructed ponds that were made over here, and then you can see some of that land was cleared down by the road. So it's helpful to look at those as well. So today, this parcel is used, obviously, by EFUD to source water for the town of Waterbury, and also as a place of recreation. Some known recreation is mountain biking, birding, walking and running, skiing and snowshoeing, foraging. So people, as you know, have been using this quite a lot. This is Lena snowshoeing as we were out on the parcel. It's lovely for that. And due to continued development of these unauthorized mountain bike trails, the parcel was closed to the public last year. So I just kind of want to give you, in conclusion, some context of this piece of land within the broader history and culture of Vermont. So the history of this land really closely mirrors a lot of Vermont's sort of overall land use history. There was the lumbering, sheep farming, small-scale hill farms and mills that were really these quintessential pieces of Vermont history. This image is from a nearby hill farm in Waterbury from Little River State Park, which might have looked kind of similar to what was happening on our parcel. And it really relates to the culture of Vermont today. Vermonters really value our beautiful natural areas, habitat for wildlife, and of course access to safe and clean drinking water. And it was very apparent to us doing this history that this is a very special piece of land, as important to the history and culture of Vermont as a whole. Yeah. All right, so we have about 5 minutes for questions about this particular topic. I guess I'll scroll back up.
Just curious, did you find any, evidence of the history of the firing range that was in there?
Oh, we didn't. I would love to hear more about that, though.
That's what I wondered. I didn't know what the history of that is. But.
Yeah, interesting. No, I don't think we saw anything about that.
That's a known thing that there was a firing range on
Bill, did you want to reflect on that?
There is no firing range. There was a firing range.
Yeah.
That's the reflection.
So, we don't know when it started or how long.
Now, I mean, it had been loosely, that area was a gravel pit.
Yeah.
That which is right, the gate most closely to Stowe. That area was a gravel pit for gravel that probably went on the Waterworks Road, maybe Stowe Hollow Road.
Yeah.
And then it kind of morphed into an informal shooting range. And then the police kind of used it as a shooting range, and then the shooting activities were terminated. It was my understanding that one rectangular box that you showed as a possible collection portion for the water system was actually used by, somebody had told me this, used to cool dairy products and other things.
Oh, interesting.
And such, that was it. It was not part of the water system.
Okay,
I know that.
good to know. We're not sure what this is for.
It looks very similar to all of our other
Yeah, yeah.
water structures.
Interesting. Yeah, that makes sense why it's so close to the house.
Yes.
Yeah. Very cool. Mhm.
The picture that you showed of the larger blocks, kind of a high wall, was that part of the mill? There was a proposed mill up there, well, but proposed, it was an existing, like sawmill, water power.
Mhm. Yeah, that was one of our theories, is that this might have been part of a mill. We're not certain of what it was for, but that was one of the speculations that we had about it. Yeah.
Where was that located? Is it on?
This one, yeah, it's right off of the road. I'll go back up to this map. It was sort of up by this second circle here. It's this second foundation up here. So it's like right next to that main waterworks road.
I believe that foundation was a barn.
Okay.
There is a mill, what I believe a mill foundation further south.
Further back. Okay.
By the
When we went out with the geologist Stephen Wright, he was saying that anyone who had built a mill at that location would quickly have gone out of business because of the hydrology was just not set up for powering. So it sounds like it was maybe a barn.
Yeah.
There was a mill site up the primary
Yeah.
center brook that I don't know how long that was in business, but
Yeah.
it's pretty quick acting spring runoff.
Mhm.
There's a remnants of an old dam there, is that?
I believe they called those mills like thunder shower mills. You could utilize them when it rained and poured, but you're out of luck.
Yeah, no, I'm not, I think, I know what you're talking
Yeah.
about, the one further upstream, and yeah, that seems like just not the foundation for this.
Great. Yeah.
Was archaeology digs any part of this, your study?
It was not. We didn't have time to fully do digs. Also, the ground was frozen for most of the time that we were studying it, so it would have been difficult. But yeah, it would be interesting to do a dig at one of those structures that we found. But no, we didn't dig up too much. We just sort of saw whatever was laying on the ground around the structure.
Are there any locations that would indicate, potential use by Native Americans or anything?
Not that we saw, and I don't believe there are many records of that. I'm sure there might be something somewhere on the parcel. That would be something you can also sometimes see things in LiDAR, sometimes not. But I think if you don't already know where they are, it's pretty difficult to locate, but certainly possible, yeah. I think we're about at time for the questions. We'll have a larger question time at the end of everyone's presentations if you think of more things that you're curious about. But I think
okay. So next we're going to be talking about enduring features, and these are the features that last on the landscape for many, many years, including bedrock, topography, glacial history, surface waters, and soil. And so kind of the background and methods that we considered going into this section are, exploring the enduring features and how they reveal key characteristics of the waterworks parcel, considering how enduring features impact erosion and recreational potential of the parcel. And to answer some of these questions, we walked key areas on Waterworks parcel, including along Merriam and Tyler Brooks, as well as areas just east and west of Waterworks Road. And I wanted to start by looking at a timeline that kind of helps visualize when some of these enduring features formed. So starting in the Cambrian period, 500 to 600 million years ago, is when rocks metamorphosed to form the existing bedrock on the parcel. And then in the Devonian period, 300 to 500 million years ago, is when the tectonic plates collided, there was uplift, and the Worcester Mountains formed. And so you can consider that as when the existing topography of the parcel was created. And then later, around 200 million years ago to 11,000 years ago, is when the Laurentide ice sheet would have been covering the parcel, and those glaciers deposited glacial till. I'm going to talk about that more in a second. But that glacial till eventually weathered over the course of thousands of years to create the soils that are existing on Waterworks parcel today. And so you can think of the bedrock as really like the backbone of the parcel itself. And we found three main types of bedrock that are listed on the ANR Atlas for this area, and that is amphibolite, schist with quartzite, and greenstone. And all of these bedrock types are pretty dense, and they are pretty much impermeable to water. So water can really only pass through these bedrock layers if there are fractures or cracks in the rocks, as shown in this photo here. And this is exposed bedrock on Waterworks parcel that you can see just north of Waterworks Road along Tyler Brook. And I know many of you are familiar with topography of the parcel, but this is also another characteristic element of the site, with the flatter area kind of in the southwest corner of the parcel, and then steepness and slope increasing as you go in the northward and eastward directions. And this, the topography creates the gradient that allows the streams to flow, and it also makes the parcel appealing for recreation as well. And so I want to do a deeper dive into the glacial history and soil formation on the parcel. So this map shows the Laurentide ice sheet, which was a glacial ice sheet that originated in Greenland and stretched across most of northern North America. So it covered all of Canada and New England, and so you can see Vermont is here in the bottom corner of the glacial ice sheet. And so these glaciers were eroding mountains, widening valleys, depositing sediment, ice, and rock. And glaciers moving through the Worcester Range would have scraped away any soil that was pre-existing to the glaciers. And then when the glaciers started melting, they actually deposited what's called glacial till, which is an unsorted mixture of clay, silt, sand, gravel, and boulders. And this glacial till would have been compacted under the weight of the glaciers that were still melting away. So this till would have been very dense and also pretty impermeable to water. And so this map shows the deposition of glacial till in pink across the state of Vermont, and this box kind of outlines relative location of the parcel. So there is glacial till that was deposited where the parcel is today. And one feature you can look for to kind of see where glaciers might have been and how they were moving are glacial striations, which are scrapes across exposed rock. Usually they're pretty uniform, all moving in the same direction, and they kind of show you how glaciers were moving across that landscape. Since most of our field work was conducted when there was still snow on the ground, we didn't see glacial striations, but I'm sure they're on the parcel, especially if you go up in those higher elevation areas. Something that is interesting to note is when we were walking the parcel with Stephen Wright, who is the glacial geologist associated with UVM, he noted that there were not clear glacial striations along the stream banks themselves, And this tells us that likely the topography of the stream banks was established before the glaciers came through. And so, again, that glacial trail is laid down and over time weathers, and that's what created the existing soil types of the parcel. And I'm not going to break down all the different soil types because there are a variety of them. Most of them in the higher elevation northern section of the parcel are a variety of silty, rocky loams. And there is this unique area here shown in orange that is a sandier soil zone. And I will talk about how that was formed. So that sandy soil zone is part of an alluvial fan. And if you've never heard that term before, alluvial fans are formed when steep mountain streams hit a flat plain and they deposit all the sediment that they've been carrying from upstream. And that sandy sediment is deposited over time and it creates this cone that kind of is pushed out and out over time. And so this is like an above aerial photo of what an alluvial fan looks like. But if we look at the topography lines of the parcel outlined by this red box, we can actually see where those, I know it's hard to see because it's kind of blown out, but there are curves in the topography lines that show where that alluvial form is on the landscape. And this is important to note since alluvial fans can be pretty dynamic environments over time because you have feet of sandy soil and then streams that are coming through this area. And so on a long time frame, thinking decades to centuries, there can be major shifts in the way waterways are moving through an alluvial fan area. And there can also be immediate shifts if you have an event like a flash flood per se. And so to take a closer look at soil drainage and erodibility, again, the site has a variety of rocky silt loams. The soils themselves are pretty shallow. You only have 10 to 40 inches before you hit bedrock in most places. And that high bedrock means we have, higher groundwater levels and more surface water that's being pushed up in the parcel. And even if a soil type is listed as well draining, it's not going to drain that well because the bedrock's not that far below the surface of the soil. There are some erosion potential factors that are listed for certain soil types on the ANR Atlas. And we found that generally the siltier soils in the northern upper section of the parcel have a higher erosion rate. And the sandy alluvial fan section has a lower erosion rate. However, we did see signs of erosion in that sandy soil zone as well. And we also saw signs of erosion when we were walking along Tyler and Merriam Brook. And I do have some photos that show that erosion. So one spot here to the far left shows the access road that runs near Merriam Brook. The central image is stream bank erosion in the sandy soil zone west of Waterworks Road, and the last image is east of Waterworks Road, right along Tyler Brook. And so taking these different soil types and erosion potential into consideration when you're thinking about the existing trails that are on the site, and also if you do want to open up the site again for recreation in the future. So you'd want to think about creating buffer widths from streams to trails. Different buffer widths are recommended for different uses, like hiking to biking has different buffer widths. And as you can see now, the existing trail map, some of these trails are going right up along the banks of the stream. Some of them are even crossing the streams. And steeper slopes are the most susceptible to runoff and erosion. And so some effective trail design strategies might be putting in staircases, using switchbacks or water bars. And this photo shows a water bar, and basically it's just a raised ledge that sheet flow will kind of hit that water bar and be directed off to the side of the trail. So you're not allowing water to just shoot down the trail, pick up speed and sediment as it goes. And so we think if trails are sited, designed, and maintained well, then they may have a negligible impact on water turbidity. But I did bold maintenance because I think that's important not only for existing trails and roads that are on the site, but for any new trails if they are developed in the future. All trails will require maintenance to prevent erosion over time. And this is just a note to say that the access roads do contribute to erosion and sediment in the streams as well. And so to take a closer look at the surface waters, of course, the main brooks, Thatcher, Merriam, and Tyler, are the main surface waters of the site. They all flow towards the southwest where there is that wetland complex along Stowe Hollow Road. And all three of those streams do eventually drain into the Winooski River. There has been no standing water or inundation flood that we could find record of that has impacted the parcel. But since the streams are moving downslope and they can carry a large volume of water, there is a flash flood risk for the three streams. And I'm going to talk about that more in a bit too. But you can see this photo here in the far left is looking down at Tyler Brook, and the banks do get pretty steep as you go up higher in elevation. And so the EFUD Commission has been collecting data that shows water quality turbidity of the main streams since 1992. And they have a graph that shows there has been, yearly increase pretty steadily since they started collecting that data. And we thought it would be interesting to kind of run a seasonal analysis on that data to try to see if there are any peaks in turbidity that line up with certain months out of the year. And so this is a box plot graph. 50% of the data for each month is in the box itself, and then the highest 25% and the lowest 25% are represented by the lines on either side of the box, and then the points at the top are kind of outlier data points. And so actually looking at this, there's not really a spike for any month in particular, but we do see a slight increase in average turbidity for the months of April, May, and October, which does kind of line up with spring rains, also snow melt in the spring, and when trees aren't fully leafed out, and those leaves wouldn't be there to intercept rainfall. And then the spike in October might line up with late season rainfalls or storm bursts, things like that. But I do think it'd be interesting to keep analyzing this data because there are trends that are being revealed, an increase in turbidity over time, but also a slight increase in certain months. And I think collecting local precipitation data, maybe there is a nearby rain gauge at Waterbury Reservoir, and so I think comparing, that precipitation data along with the data EFUD is already collecting would be interesting to keep looking into that. And so, as I said, there's no inundation flood risk for the parcel, but FEMA has called out the Thatcher River corridor as an area that could see more dynamic change and erosion over time as that corridor kind of meanders. And so the wetlands actually to the southwest could be an important buffer for any of that flooding. And so during our field work, we walked pretty extensively Tyler, Merriam, Brooks, as well as the sandy soil zone. And we discovered a lot of hydraulic features such as groundwater seeps, offshoot springs, and wet areas that were not previously mapped in GIS or in the ANR Atlas. And I do think it's really important to call out these water features because a lot of them, especially the ones along Tyler Brook, are feeding the volume of water in that brook. And so these could be an important, an important resource to the future of the parcel in providing public drinking water. And here are some photos of those offshoot springs and seeps in the top three images, and then the bottom two are wet spots that we saw in that sandy soil zone. So some overall takeaways from thinking about enduring features is it's really the bedrock is pretty high, The soils can be shallow, so that's really what contributes to the high presence of water on this site and makes it valuable for public drinking. But the soils do have, they are susceptible to various forms of erosion, and so definitely something that should be considered with future use of the parcel. And I think we're ready for questions. So yeah. Yes.
The places where you identified erosion.
Yes.
I presume that there are natural causes to erosion, and then there are human aggravations and exacerbations. These the things that you've seen, are they? Can you tell us what you think the causes are, or the share of the causes?
Yeah, so I think we can't say for sure for all of the different points, but definitely along Waterworks Road, I think that is the area where those two streams are converging, which I think that leads to stream bank erosion. And I don't know if the road itself is contributing to the stream. I'm looking to see if Summer, yes, Summer, do you have anything to add to that?
I can speak to that a little bit. So a couple of those points near the top of the parcel elevation-wise are places where old access roads or logging roads of some kind, I couldn't say exactly where it is, cross streams and have a dip in elevation for quite a number of feet before they do. And so we were looking at some of those and seeing some erosion along those roads and imagining water coming off the hillside, flowing down the road and into the stream. Some of the points where we marked erosion, are below the water intakes, and so are not as much of a concern for turbidity on the lower part of the parcel. And then some of them are trails, whether legal or not. I wasn't referencing them not while we were there, but there are places where trails do the same thing I just described with the road, where there's a downward slope on a trail that comes right up to a stream or crosses a stream. So both roads and trails are doing that from a human perspective. And then I think in those alluvial fan areas, towards the bottom of the parcel, there's areas where we saw a lot of bank erosion that may have nothing to do with any human infrastructure. It's just rivers eroding sand equivalent.
Thank you.
Yeah.
But even if the trails and roads aren't in use, they could still be contributing sediment towards the stream. So. Any other questions? Yes.
This is a technical question, not so much. You referenced different types of groundwater discharge, seeps versus the other one?
Offshoot streams. Yeah. So
offshoot stream?
Yeah.
Or I thought you said offshoot spring.
Oh, I might have. Yeah. So the way that we were identifying if it's a seep is just trying to walk to the top of that feature and see if it's just kind of coming out of the ground. And if it was labeled as a stream, that means that we followed it for a long period of time and it seemed to be flowing down the mountain itself. Yes.
Yeah, in fact, I appreciate the human history juxtaposed with the substrate. I didn't really pick up history of mining or extraction, either bedrock or superficial materials on the site.
Mm-hmm.
What's the story?
I'm not sure. Our group did not look into the copper mine that much. I don't know if...
I believe there was briefly a copper mine. And what we found from newspaper records was like an announcement that stuff was found and it was going to be very profitable, and then we found no other newspapers about it. So,
the copper gold rush?
Yeah.
They gobbled it up for themselves.
Well, and there's the rock quarry. I don't know, but I've heard it was related to, was used maybe for some of the interstate construction that they told you, is that right?
That's further down Sweet Road. Yeah.
Okay, so that's not on the.
Not on this parcel.
No, we didn't go there actually recently, right? But yeah, it's not on the water.
Yeah, it's right off the Hunger Mountain Trail.
Yes.
That
Oh,
parking
that's
lot.
good.
Yeah.
And we did see glacial striations there, right, at that location?
Yeah.
Yeah. I think we have time for one more question. Yes.
If you were looking to
find a well site, an additional well site, where would you look? That's the geology question.
Ooh, that's a really good question. And I don't know if I'm qualified to answer that. Yeah, could you blast through the bedrock, I assume? Yeah. I don't know. Does anybody have ideas? Yeah. The sense that I'm getting is that there is a lot of groundwater throughout the parcel. And I don't know, like, does the type of soil impact the stability of a well over time? So you might not want to locate it in that alluvial fan area. And you probably don't want to go super upslope either, but yeah. Good question. Sorry, I couldn't answer fully.
They call it fracture trace analysis or something to determine likelihood.
Oh, and now we're taking an intermission, a 5-minute intermission.
All right. So we on the plant team decided to do 3 things. Do a survey and an inventory of what plants we could find on the property. Also do a delineation of what natural communities we could find on the property, and also assess the health of the plant communities on the property. And so we found 122 plant species in total. 53 of them were herbs, 16 shrubs, 12 fern and fern allies, and 41 trees.
So I'm going to talk about the natural communities we identified on the property. And so what's a natural community? So a natural community is a recurring interacting assemblage of plants, animals, and other organisms that inhabit a specific physical environment. So natural communities are identified based on vegetation, geology, land use history, topography. A lot of different considerations go into determining the identity of a natural community. And so we relied really heavily on this book, Wetland, Woodland, Wildland. If you don't have a copy, get a copy. It's awesome. And we identified and mapped 12 distinct natural community types, 6 of which are upland natural communities and 6 are wetland natural communities. So I'm going to expand this so we can see the natural community delineations. So, sorry it's blurry. So just really quickly, a lot of brown area here. You can see that, so Northern Hardwood Community, especially east of Waterworks Road, is really the matrix or the most dominant forest type. We also have several variants of that Northern Hardwood Community type. So in pink, we have hemlock Northern Hardwood. In purple, we have red spruce Northern Hardwood. Up at the top of the property, we have montane spruce fir forest with red spruce Northern Hardwood forest just below it. These 2 areas up there, we have montane yellow birch spruce fir forest. And then, of course, on the western side of the property, really difficult to see. I'm sorry about that, but that's primarily where the wetland natural communities are. And so we were also guided by, I think I saw Dan in the room here. So we started with the map of natural communities that you created in 2019. Use that as a starting point and really work to redefine or verify and redefine, maybe redescribe some of those natural communities. And here's just an example of, again, sorry it's so hard to see, your map on the left versus what we mapped this round here. Here we have a graph of the percent land cover by natural community type. And as I was saying, again, really difficult to see. Oh, there we go. Maybe that's a little bit better. So Northern Hardwood, the brown bar on the top, 57.81% of the of the total area was mapped as northern hardwood forest, followed by hemlock, northern hardwood, red spruce, northern hardwood, alder swamp, lowland spruce fir, and then it continues. So of the 12 natural communities we identified, 4 are state-recognized S3 natural communities. And so according to the state, an S3 designation indicates basically that natural community type is uncommon. So the way the state's ranking system works is S1 is very rare, S2 is rare, S3 is uncommon, S4 is common, and S5 is least concern. And so again, 4 S3 or uncommon natural community types were identified on the property. And so those are the hemlock, balsam fir, black ash seepage swamp, which is the photo on the left, lowland spruce fir forest, montane spruce fir forest, and montane yellow birch red spruce forest. It's important to note that we did observe either trails or evidence of trail construction in each of these 4 S3 community types. We also recognized anthropogenic habitats, so these are the maintained, primarily the mowed fields in the western portion of the property, which are dominated by reed canary grass, sensitive fern, common dandelion, the occasional apple tree, and then with a lot of Morrow's honeysuckle and raspberry in the hedgerows and along field edges. So next we performed an analysis of the forest structure on the property. So we started this process by taking data from the 2019 Forest Management Plan, charting it out and trying to create a visual of where basal area is concentrated by tree size class. Here's the result of that. Basically, what you can see is that a lot of the basal area in the forested, on the forested portions of the property, or tree sizes, is concentrated in the lower size classes. So we had 3 stands, which are the gray boxes, stands 6, 7, and 12, where basal area was actually captured in the 18 to 22 inch and 24 inch plus size classes. So next we pulled together a normalized digital surface model, also known as an NDSM, to visualize vegetation height and forest canopy across the property. Here's a map of the results of that effort. So basically, what an NDSM does is it maps vegetation height, and it allows you to assess canopy dynamics, and then also helps visualize different habitat types. And so really interesting, just kind of zooming in more. So this area here, very red, that's the red pine plantation. So a very red, uniform, very even canopy height in that plantation. So you move across the road and look at other forested portions of the property. The darker red areas, those are the plantations. And then within the larger forest, you can kind of see here, it's mostly closed canopy with very few large canopy gaps and not a lot of early successional habitat.
Invasives? All right. So as part of assessing the forest health, we also did a non-native invasive species survey, looking at what insects and what plants are invasive on the property. In 2024, it was reported that the emerald ash borer was present in the town of Stowe, and so it prompted us to do a good survey on the property to find signs of the presence of this species. And we did find evidence of crown dieback and vertical bark splits and some woodpecker activity on ash trees on the property. If I could zoom in to get this photo to show properly, you would see some striations on the first back, indicating some S-shaped beetle galleries along the bark of the tree. You would also find some woodpecker flecking activities on the two trees, which aren't shown correctly here. We did capture an image which we sent to the A&R for confirmation. However, they couldn't give us a positive feedback on that because of the heavy drilling activity made by the woodpecker on the tree bark.
Can I say a word about this?
Yeah.
So yeah, this is a photo of a tree near the upper extent of the property, kind of near the transition from northern hardwood forest to that montane yellow birch red spruce forest. I'm going to scroll down just a bit. So I was trying to get a photo of this way above my head, and I was trying to get a photo of that. It's really difficult to see, but to my eye, it looked D-shaped. And as Isaac said, a D-shaped exit hole is a telltale sign for emerald ash borer larvae leaving that tree. I sent this to Vermont Invasives, and because of the damage around the hole, they couldn't definitively say whether or not it was emerald ash borer. The other night, I was formatting this photo in our report, and I noticed upper right corner, there's another hole, which is very clearly D-shaped.
So that was it for the insects. We did a similar survey for plants, and we found 11 non-native non-native plants on the property. Some of the non-native plants weren't invasive, so it was a combination of them. However, 2 of these non-native plants were invasive species of concern. That's the Moro honeysuckle and the Japanese barberry, which has quite a broad distribution across the property. We found patches of these plants across almost every corner of the plant, especially over the wetland areas and some of the montane areas too as well. So here's a photo of the Japanese barberry. Usually has thorns spiking up from the branches and very bright red fruits if it bears them. We also performed a habitat suitability model for 2 of the invasive species we found, the Morus honeysuckle and the European buckthorn. The model, or the habitat suitability model, essentially predicts or tries to tell us whether or not an area is suitable for the establishment of a species. And this model is built by a combination of weather variables, which includes precipitation and temperature across the months, and the presence of the species on the area. And right here is marked, or the boundary marked here is the boundaries of EFAD. And our model showed that EFAD is, or the waterworks property, is a prime area for the establishment of the species in the current climatic conditions and in future climatic conditions as well for both species. So for Lonicera moroi and for the Rhamnus cathartica, which is the European buckthorn, parts of the property indicate indicates good areas for the establishment of these species. And so in conclusion, we identified 122 species and delineated natural communities within 2 portions, wetland and upland. The property has 4 natural communities that are of ecological concern and should be protected and managed properly. There is a lack of size class diversity amongst the trees on the property, and so if there's any disturbance or any thing that can, or any disease that can wipe away the plants on those communities, they might not be able to withstand. Also, there are surely indicated presence and signs of the emerald ash borer on the property. Parts of the waterworks property has invasive species present, and they must be managed or controlled. Thank you. We will take questions.
Yeah.
The S3 areas, the 4 S3 areas, is there a certain minimum size of such an area before it can be designated any one of those classifications? I'm just curious, I don't.
That's a question. That's a great question. I'm not aware of a minimum size. I think in general, I'm trying to remember what Bob told us, if anybody remembers, but I think so Bob Zano, the natural communities ecologist for the state of Vermont, seems like anything less than an acre, he kind of, doesn't bother with. But that being said, I believe all of the S4 communities are greater than an acre on this property.
And one other quick question. The non-native invasive species, in particular the two that you are articulating some concern about, two parts to the question. I'm just curious, how did we think they got there? And two, what do we need to do to manage them?
So for emerald ash borer, it's an insect and obviously moves around. And like I said, the stow has reported its presence, and so it makes the property a prime area for movement. Also, there are ash trees on the property, and so that obviously is a place where they can settle on. And for the plants, usually anthropogenic activities, and which are the large drivers. And so for your recreational activity, people moving in during the summer, and times when things are blooming are very prime time for the spread of such species.
I think there was a second part about.
Well, is there anything, the plant species, ash borer is a whole different problem. Is there anything we can do or should do to?
Yes.
So, so in our report, we are writing a recommendation that you maybe have some conversations with the Vermont Youth Conservation Corps, because they have groups of young adults who will go out and do physical removal of invasive plants.
Right, good, okay, thank you.
Did your group come up with any recommendations as far as broad scale forest management ideas on, if the significant portion of that property is older growth, not old growth, but older growth, and there's very little early successional habitat. If the mission is water quality, do you include recommendations on broad scale forest practices moving forward?
That's a great question. So we started thinking about, suggestions to improve early successional habitat. Then when we discovered the more definitive sign of emerald ash borer, that early successional habitat is going to be created by emerald ash borer taking out those trees. So we didn't really spend a lot of time thinking about the, intentionally creating that and the implications of that, just knowing that it's going to happen whether or not you want it to.
Is it are you suggesting that the early successional habitat would be of benefit to water quality specifically, though, compared to if the interest wasn't as much in, say, wildlife habitat or early successional habitat? Would leaving it alone be more beneficial, or would creating early successional habitat in certain areas? I'm just wondering if you addressed that.
So we didn't directly address that, and I'm not sure if you're familiar with the Hubbard Brook Research Forest. But they did a study years ago where they basically, clear-cut a section of forest, which then, of course, turns into early successional habitat, and compared that to mature forest, and found that water quality, stream sedimentation, increased exponentially in and around that harvest area in that early successional area.
Yeah, thanks. I think that's important for especially the commissioners as they kind of plan all this.
Yeah, I also want to say something about that Nick actually had brought up before as well as part of the concern about lack of early successional forest isn't necessarily we have too much older forest. In the forest structure map that we showed, it looks very uniform, and you're like, oh, it's like all yellow and red, it's because it is. And so part of the forest health, which contributes to water quality and soil quality, is like having overall like structural differences. And so with all of the trees being roughly the same size, roughly the same age, we just really like, in a general forest health perspective, you want diversity in your forest structure. So, and like, yeah, thank you for probably saying more on that, but I wanted to make sure that.
Yeah, that was perfect, thank you. Yeah.
The map that showed the S1, 2, 3, 1, 2, 5, you were mentioned there are a couple of lower tier, is there ones and twos up there?
So basically, 1 would be the highest priority.
Yeah.
And then 5 would be the lowest.
So, and we have some ones and twos.
No, we have 3s. Only 3s.
Oh, only 3s and up.
Okay.
But we do have trails within the 3s?
Yes. You have trails within the 3s.
And where are those on that map?
The trail locations?
The
Yeah.
3,
Yeah.
have the special.
So
S3.
the S3. So Montane Spruce Fir Forest. So right here, this green.
Yeah.
So way at the top of the property, above 2,000 feet in elevation. I was up there, and somebody in recent years had been cutting branches off of trees, and it looked like starting the formation of a trail. It didn't look like it was heavily used, but somebody was up there doing something in recent times. I also found a shovel just below it.
Is that the Cambrian?
Yeah. So the second, the Montane Yellow Birch Red Spruce Fir Forest, or not Red Spruce Forest. So these 2 polygons here, which do extend off of the property. So this area doesn't look very big, but it extends off the property. So just to that size question. So there's a trail that goes up the southern edge of this polygon here, which it looks like that trail has been there for some time. It's an old logging road.
Yeah, it's a little logging road that access state land.
Yeah, and it looks like that trail maybe has been used in recent years for recreational purposes. And then zooming in here, lowland spruce fir forest. The purple here, there are kind of trails all over the place.
That's on the flats?
That's on the flats, yep. And then the hemlock-dominated seepage swamp, which you can see that if you go to the kind of the main parking area at the gate, kind of on the near the Waterbury Stowe town line, walk through the Norway spruce plantation, and you drop down into the seepage swamp. It's actually a really cool area.
And where is that on the map?
That is the lower left corner.
I don't see your cursor anywhere.
Yeah.
Oh, there it is. Okay.
Yep.
What are the 2 light green ones, the small polygons?
These here?
On the other side of the road. Yeah, those.
Right here, so those are woodland seeps.
Oh.
So those are, a lot of people refer to seeps as springs, so areas where groundwater is literally coming to the surface.
Discharge.
Yep.
We might not know this answer, but maybe some forest you are in, or people do, but there are reasons, and there probably aren't enough ash to warrant, any taking it for any resource, and there are reasons not to go in there and do so, but is there any evidence that felling ash trees has a significant decrease on the reproduction of emerald ash borer, or do the trees die soon enough that it's not a significant difference?
I'm not aware of any research related to cutting trees to slow the spread or stop it once it's there. It's very likely it's already here and it's throughout. So cutting all the trees down is actually going to damage the long-term survival of ash species on that property. So there is about a 90% mortality rate. The thing is, if you go in and you cut down all the ash trees, those 10% that might be survivors, you're losing their genetics. And so those trees will be lost from that landscape. And so, any panic cutting, we would definitely advise against. Yeah.
When was the last time it was logged up there?
And we did extend, Dan, you want to answer that one?
I was just trying to think of when the last time was.
I mean, we did extensive logging in the 90s.
Yeah. There was some in the 2010s, wasn't there?
There was some smaller
stuff, right? But, early 2000s was the last.
Yeah. Is there a plan to continue and do more logging?
We have a forest management plan.
Yeah.
It's always on the table.
Alrighty. Well, myself and my two other teammates from the wildlife team are all going to be speaking at different portions of this presentation. So yeah, we first just wanted to address that the Waterworks parcel's undeveloped forests and available water resources that contribute to clean drinking water objectives are also what make the Waterworks parcel really attractive for a wide diversity of native wildlife. I'll play this video again. This is a bobcat crossing Tyler Brook, and this is at our first camera site, and it's just downstream from Tyler Brook Dam. And so our team really had five main objectives going into this project. The first one is that we wanted to understand this parcel's role in connectivity within the parcel as well as regionally. We also wanted to inventory what wildlife species are present here on this parcel. We wanted to identify different wildlife features on this parcel that are supporting these species. We wanted to understand the role of beaver and the status of beaver within this parcel. Also, we wanted to look into how trails and trail recreation may be impacting wildlife. And our last objective was to take into account resources that you already had, such as the Forest Resource Management Plan from 2019, as well as Steve Hagenboo's bird habitat assessment. So we set out over the course of 3 months, 14 different camera traps, and we really wanted to place one camera in each natural community type so we could tell the story of the wildlife and their connections to these different natural communities. We were building off of the natural community map from the 2019 Forest Research Plan, and we really prioritized placing those cameras in locations where we observed concentrations of wildlife sign or natural movement funnels on the landscape, such as riparian corridors and stream crossings, different like movement funnels on the landscape. So here's a couple photos of our awesome wildlife team. On the left, we have Clara setting up a camera trap in the alder swamp within the wetland complex in the lower portion of the parcel. This camera is out looking over a beaver dam and a beaver pond. And then on the right is Clara and Gordon setting up or maybe checking the camera from Tyler Brook, the footage of the bobcat in the beginning of my presentation. That is the camera that captured that footage. And that was at a stream crossing. And so our camera placement doesn't really allow us to draw statistical conclusions about wildlife population, but we can provide observations and trends based off of our research. And so we did some desktop research as well using GIS like the other teams. And so here is a map of the parcel, and the little black icons spread throughout the parcel are our camera trap locations. And you can see that a number of them are condensed within the wetland complex down here, where we noticed many signs of wildlife. And so thinking about regional context, we really wanted to incorporate some of Vermont Conservation Design's resources into this project. And Vermont Conservation Design really identifies the most important lands and waters needed to sustain the state's biodiversity, and it provides a science-based blueprint for protecting ecological function, habitat connectivity, and climate resilience. And one of their resources with Vermont Agency of Natural Resources is this mapping tool. And so here I have pulled up, it's called BioFinder, the EFUD parcel. And the parcel boundary is on there, but I have the layer turned on of wildlife road crossing, which is these chunky blue blocks, and these are laid over Waterworks Road, and you can see that most of Waterworks Road is highlighted as high priority wildlife road crossing, and a high priority wildlife road crossing, or a wildlife road crossing, is a road that is bordered by vegetation on both sides, which is often connecting different forested blocks, which are areas where wildlife can safely move from one forest to the next. And also, it's important to point out that Vermont Conservation Design has deemed, I believe, Thatcher, Merriam, and Tyler Brooks all as high priority riparian connectivity, which are riparian areas that wildlife can safely move through, as well as priority interior forest and geological diversity. Let me see if I can zoom out here one moment. Oh. Give me a second. There we go. Okay, and thinking more closely about connectivity, which Vermont Conservation Design highlights, here I have a map of the Schutzville Hill Wildlife Corridor. And why is this parcel important when thinking about connectivity? Because it really adds an additional 500 acres to the large 13,000 acre C.C. Putnam State Forest block. So we have the EFUD parcel right here circled in orange. And it's providing a huge chunk of land, sort of connecting east to west movement for wildlife from the Worcester Range, which we have on the right, and the broader Green Mountains and Mount Mansfield on the left. And in Vermont, east to west connectivity for wildlife is really hard because we have a lot of really high trafficked roads and interstates that are running north to south. And so Stowe Land Trust has identified the Schutzville Hill Wildlife Corridor as really the last remaining linkage between the Worcester Range and the Greens. And the wildlife corridor itself is right here in this area. That's a moose at the Schutzville Hill Wildlife Corridor crossing. And so, yeah, many species that we detected through our camera trap efforts, they really depend on these large forested blocks. They span, their ranges can span thousands of acres. It's a bobcat that we observed at our camera site number 13. Thank you.
And so to sort of drill into the pieces of the parcel that facilitate the connectivity in the wildlife habitat, I'm going to go over what we are calling priority habitat areas. This is me crossing a beaver dam to try and access one of the camera sites in the wetland complex. And that's what we'll start at the wetland complex, which is maintained and created by beavers. This beaver is repairing the dam a few hours after I walked over the dam. So this is same day, a few hours later at night. And we just want to highlight that the wetland complex is made up of the alder swamps, the open water, and the shallow emergent marsh. So it has a diversity of plant species, which leads, and a diversity of habitats, which leads to a diversity of animals. And all of that is facilitated by the beaver. So things that live in this is the alder swamp. Things that live in the alder swamp are breeding birds often that don't use forest. So this is one of the only early successional habitat areas on the landscape. It's also, if you can't tell, super dense, hence why we were walking across the beaver dam, because we can't get through this alder swamp. But things like bobcat and bear love the dense vegetation for movement pathways and for habitat cover. And bear and moose will use alder swamps to forage for vegetation. So what we also have, this is a graph of all of the wildlife observations, the number of species per new natural community type. And what you can see is the alder swamp, where we had a camera, had the most diversity of species compared to the upland areas. So there are things like mink using the alder swamp and the wetland complex, things like river otters, fishing in the open areas created by the beaver dam. There are things like 3 otters. We just love this video because it shows the community of otters that live in the Beaver Dam wetland complex area. And you can't hear it fully, but they're chittering and they're talking to each other, and it was incredible. Every time we saw one of these, every time we saw any cool animal on our camera, we pumped our fists and got really excited in the middle of the woods by ourselves. The next area I'll talk about is one of the S3 natural communities, the hemlock, balsam fir, black ash seepage swamp. And it's a rare or an uncommon natural community, so its vegetation and its structure is different than that of the rest of the parcel, and difference breeds diversity, and so it's a crucial area for things like bobcat to move through, and coyote. We saw barred owl in this area. And yeah, just reiterating that having a diversity of habitat types leads to a diversity of wildlife species. I'm pausing because there's one more. So Darian touched on this a second ago, but there are riparian corridors throughout the property. It's interesting, the whole property is forested, but the riparian areas often act as funnels or as paths of least resistance for animals, so they'll often congregate around rivers as they move through the landscape. And also wildlife are attracted to the source of water in upland areas. Here's some deer using a riparian corridor on Tyler Brook, I believe. The next area that we wanted to talk about is the red oak northern hardwood forest. It's the area in the northern part of the forest, of the parcel, that has a higher concentration of red oaks. Red oaks are crucial for many, many wildlife species. Exhibit A is the magical acorn that feeds things like porcupines and bears and squirrels and blue jays. But what's also important about red oaks is that they support insect populations that support warblers and birds of all kinds. So it's not just this hard mass that we're talking about, but also the habitat for insects. And here's a porcupine friend that's apparently playing in slow motion in the northern red oak northern hardwood forest. Now, so transitioning, those were areas. Now I want to talk about points. So we're calling crucial points on the landscape for wildlife habitat features versus habitat areas. And one that's very well represented on the parcel are these rocky ledges and cliffs, especially in the northeastern area of the parcel. So these areas are perfect for denning sites for bobcat and bear and porcupine. They're areas where wildlife can seek refuge and get away from other creatures and human activity and things like that. This is a porcupine den, this little crevice. So we also saw our only bear. This is on a bench between two cliffs in a wet area. Yes, and then another point that we wanted to talk about were mass trees. We already talked about red oaks, but beach trees also provide food for all the same animals. And then I also just wanted to mention the soft-mast trees, things like apples that are on the property, and black cherries are also areas that concentrate wildlife around them. Sticking on the tree subject, sometimes trees are more valuable to wildlife when they're dead as opposed to when they're alive. So snags are standing dead trees that are habitat, again, for insects, so supporting bird populations. And then when woodpeckers get in there looking for insects and carving up the trees, they make homes for things like black-capped chickadees and fisher cats and screech owls and things like that. Just another example of a snag. And here is just a wild video of a fisher in the snow that might use one of these snags as a place to den. In the dead wood area, so these are standing dead trees. When you think about wood, trees on the ground are also crucial for wildlife. So down woody material provides habitat and cover for birds that use lower portions of the forest and amphibians and things like that. So it's important to keep, whether it's from wind throw or whether it's from logging, it's important to keep some down woody material on the forest floor. The last one I'll talk about, I believe, is the woodland seeps that have been mentioned before. Seeps have, again, different assemblages of plants. They're often more open than the rest of the forest, and they're very wet, and so they attract different species. Amphibians use seeps. Bears will dig out seeps to make bear wallows that they'll return to throughout the summer to cool off. And even woodcocks will sometimes use the open areas in seeps to do their little display dances in the early spring. And here is a red-effed, just one of the amphibians that we've observed on the parcel that uses these seeps.
Okay, so let's get into some specifics about the wildlife species that we noted are at the waterworks, starting with birds. So we were in the field doing field work between February and April, which you may know is not an ideal time to be doing bird surveys. Most of them had not come back from their winter vacations yet. But fortunately for us, people have been paying attention to the birds at the waterworks for a long time. And so we were able to use eBird data and get a sense of what birds are at the waterworks through that. And eBird, if you're not familiar with it, is a very popular app and online database where birders can keep lists of the bird species that they observe at a given location, and it's geo-referenced. And so we downloaded that data and found that in the last 10 years, eBird users have observed 100 different bird species at the waterworks. And there are 201 breeding bird species in Vermont. So 100 is a pretty sizable chunk of that. The most frequently observed bird species that eBird users have noted are these 10 here. So moving from left to right, American goldfinch, Canada goose, chestnut-sided warbler, black-capped chickadee, crow, purple finch, red-breasted nuthatch, song sparrow, swamp sparrow, and winter wren. It's not one of the most common, but it's definitely on the list. And so another great resource that we had access to was Audubon Vermont's Forest Bird Habitat Assessment of the Waterworks, which was done in 2013, but still has a lot of incredibly relevant information in it.
And the author, Steve Hagenview, whose name has come up a few times in this presentation, describes really great habitat that the waterworks has for some of those forest nesting birds, including several species that Audubon Vermont is actively working to protect. That's birds like black-throated blue warbler over here, black-throated green warbler, scarlet tanager. And so a lot of the bird habitat that's really high quality at the waterworks is in that kind of more interior forest, which makes sense because that's the majority of the parcel. But that said, the areas that are early successional or more open kind of play an outsized role in supporting different bird species than those interior forest species on the waterworks. Moving on to mammals, our camera traps documented 19 different mammal species, which is about 1/3 of the 58 mammal species that are found in Vermont. Some of our, let's see if I can make this, it's a little glitchy, but this is a red squirrel stashing a pine cone for a snack for later. And red squirrels and raccoons were, maybe unsurprisingly, the most commonly observed species recorded on our camera traps. I think we had a red squirrel and/or raccoon on pretty much every camera. We also saw a lot of white-tailed deer, coyote, and snowshoe hares. This particular coyote is from our second camera trap, which is in the red pine plantation. And some of the less frequent flyers were bobcats, fisher, foxes, long-tailed weasel, and black bear. Can I replay this? It's like not letting me. Well, oh, there we go. Here's our coyote. We also got a lot of recordings of little mice or other small rodents that are kind of hard to identify in this particular view that our cameras give us, but they are very cute. And being on the ground at the waterworks this entire semester has really given us a lot of opportunity to find areas where that seem to be more high traffic for wildlife than other areas. And there's Gordon looking at some fresh raccoon tracks in the snow. So for example of one of those high traffic areas, we found a lot of evidence of porcupines using those rocky ledges that are at higher elevations at the waterworks. If you're not familiar with porcupine poop, that's what it looks like. And that area where the forest transitions into wetland and vice versa on the western side of the Waterworks Road is also kind of a hot spot. We saw bobcats there, on the cameras, not in person, sadly. Raccoons, foxes, coyote, deer. There's a raccoon on top of a snow-covered beaver dam. And even though we only had one camera that recorded a bear, we did see a lot of bear sign across the parcel. So this is some bear hair on a telephone pole where it was scratching on it. You can kind of see it's like bleach blonde by the sun, so it's been there a while. And these are some bear scratches on a beech tree. So one other thing that we wanted to look at was the impact of, was the impact of trails on wildlife. We wanted to take the opportunity while the trails are closed to try to look into that a bit more. And this is a photo of a mountain biking trail going across a forest seep. And the first thing that I want to emphasize is that studying how trail-based recreation impacts wildlife is really complex. different species and just different individual animals will react very differently to different situations. And there are just so many variables involved in trail-based recreation, like the type of activity, the time of year, the specific kind of like microsite conditions of where the trail is. And so it's really hard to identify trends. But that said, we relied really heavily on this 2021 study done by Meredith Naughton, a former field naturalist student for the Vermont Department of Fish and Wildlife, to look at this. And there are key takeaways that we can observe as trends over this data. So one key point is that trail-based recreation negatively impacts wildlife, period. The severity of that impact can range significantly. Kind of on the lower end of the scale would be just like an animal using more energy to avoid someone recreating on the trail. And at the more extreme end would be a local population just moving away from near the trail. Another key finding is that the zone of influence that impacts wildlife extends beyond the trail itself. So the primary zone of influence is 100 meters, and that is the distance within which most species have some kind of impact from recreation. And the secondary zone of influence is 500 meters beyond the trail itself, and that captures impacts to some of the more sensitive wildlife species, and that would include probably some of the animals that have larger overall ranges. Another key takeaway is that wildlife are more sensitive to trail-based recreation during the breeding season, which makes sense. And then also, the volume of use on a trail is not linked to increased negative impact on wildlife, which is kind of surprising, but there hasn't been a clear link between those things. So here we have a map of the trails at the waterworks. It's a little hard to see the trails, but and the different zones of influence. But we have the primary zone of influence, that 100 meters in a darker yellow in the middle, and then all of this other yellow is the secondary zone of influence that extends 500 meters beyond the trails. So as you can see, it covers pretty much the entire parcel if we look at those two zones of influence beyond the trail system in there.
Is it 100 meters on either side of the trail, or the whole zone is 100 meters?
Either side, yeah. Okay. And then this is a map that shows buffers around some of the more sensitive wildlife features that we identified on the habitat. So the wetlands in the southwestern corner, for example, or up in the northwestern corner, that area of northern red oak that really supports a lot of wildlife. All right, so that is what we found for wildlife. There's a lot going on the parcel, and now we'll get into some questions.
Yeah. So beavers are great engineers. Did you know any problematic beaver activity?
We didn't see any, well, so, yeah, no. What we were looking for is upward movement of beavers. And so far they're active, but they're active where the open water is. We know that beavers pose a risk to water quality, but currently they're well below any intakes, and they're not moving up slope at all. They're maintaining their current locations in the ponds.
And they aren't currently damming any culverts or anything like that.
But
yeah.
We know that has been a problem in the past. We just didn't see any.
Yeah. Out of curiosity, the ratio of red to gray fox?
I think we might have only seen one gray fox, is that right? Mm-hmm. And then a handful of red fox. We could look back at the numbers and get back to you on that, but I think we saw
That's right.
One gray
and
fox.
2 to 3 red foxes.
Yeah.
But they were elusive, like we saw very few foxes overall.
Right? Yeah, and if you look in our report, there is a more detailed graph that Gordon made where you see every species that we observed through a camera trap at each camera location. And so you can see a number of individuals per camera trap location. It was just a really long chart that we didn't want to bore you by throwing it in here, but that'll be in our report. Yeah. Yeah.
You found a lot of wildlife. Would you say it's higher concentration, average, low concentration for a parcel of this type?
It's a great question, and we didn't compare it to any other parcels in particular. We haven't done any research on how concentrated wildlife are in different parcels. I think one thing that's hard to understand in that sense, that's what the note at the beginning about not being able to draw statistical conclusions. We didn't systematically cover the parcel, so we can't say if the concentration in the parcel itself is X, Y, or Z, or if we can't say anything about the population because our cameras were dispersed and they were out for different amounts of time. But that being said, if you think about it from the conservation design perspective, it's an important part, but we just don't know if it's more or less than other similarly forested parcels.
But I would say the role it plays in wildlife connectivity within the region is really something to emphasize. It plays, a very important role in that, as part of that last connection between the Worcester Range and the Green Mountains. Yeah.
Well, and your study was done in a period where activity is low.
Exactly.
But also, the trails were closed.
Mm-hmm.
But historically, the activity up there has been pretty strong for many, many years. The mountain biking has increased quite a bit in the past, say, 10 years. But the wildlife is still using the parcel. Yeah, it'd be interesting if you had done the study.
Yeah,
in the mountain bike season.
Oh,
with
yeah.
bikes,
Yeah.
In the mountain bike season
Yeah.
without the bikes.
Yeah.
I'd be curious to see the results. of
Yeah, that would be really interesting.
Yeah, we did see a number of humans through our camera traps as well. So
We did.
years going by, and
No mountain bikers.
no mountain bikers.
There was still using recreationally.
Yes.
Oh yeah, all over the parcel.
Yeah.
And we saw people when we were out there,
Interesting.
like walking.
Yeah.
Bikers were being good.
Bikers.
Yeah, mostly on Waterworks Road, we see
Yeah.
people, but we did observe off of the road as well.
So one more question, the red pine plantation, is red pine a native species?
Yes, it is a native species, but it's planted there. So it's not natively growing there. It's not naturally growing, but it's a native species, if that makes sense.
To our area or southern Vermont or?
To our area, it's just rare. It's associated with fire, sorry.
No, you're good.
I need to like scoop behind you and then talk. It's associated with fire, so it tends to be patchy across the landscape.
So after a fire, it's pioneers?
Yeah.
And then
It needs bare earth and its seeds to be scarred or to like be scorched to be able to germinate.
Yeah,
most of the
so
time.
the plantation is because it grows rapidly, so the thought was to have lumber and
I think a lot of it was for like erosion from all these hill farms where the land had been really cleared and they wanted something that was going to be fast growing and got in there to help stabilize the soil.
They had programs in the 50s
Yeah.
for red pine, white pine, Norway spruce, state-sponsored programs, or farmers going out of business to revegetate to stabilize the species.
so is that species still, is it a desirable species to have?
It's super low value from an economic standpoint. It's,
From a lumber standpoint?
yeah, from a lumber standpoint, it's pretty.
Wildlife standpoint?
Well, it does provide winter cover for deer and snowshoe hare and ruffed grouse. but it does have very low structural complexity, like what the plants team was noting. It's it's really one even. That was that really red spot on the map that Nick showed. That's just like one even canopy and not a lot of understory plants going on.
Experiencing some dieback, I've noticed.
Should it be something we should be changing by managing it and
I think it's doing it on its own.
just doing it on its own?
It did provide nice habitat one year for a group of students from the Stowe High School to party all summer. I didn't notice the spot they built in the middle of the plantation until much later.
Is there bottles and cans there or something?
Oh, yeah.
What is interesting from a wildlife perspective is that it's right at the wetland edge.
Yeah.
So we actually are getting a lot of species there that are using the wetland and the edge of the wetland as a corridor for travel and for things like that. So although it's the rest, like the other side of it might not be that valuable for wildlife, at least that providing diversity of structure compared to the wetland is interesting.
Yeah, that wetland edge where the red pines are is also this real intense area of bear marking activity. Red pine is their favorite species. I mean, I've never surveyed a bear, but if you just look at the trees that bears choose to mark, there's something about the aromatics of red pine that really attracts them. Yeah, so it's always something to consider, like, the eastern side, if we were to remove all those white pine, if they just disappeared overnight, maybe the bears shouldn't mind if they were something else, but they are concentrating a lot of their communication efforts on the west side of that plantation stand.
And we'll make time, there'll be some more time afterwards to talk more, but I think it's time for the recommendations, folks.
So we've broken up our recommendations into 4 different categories. The first one is focused on trail siting and maintenance. And so our recommendations here would be to mitigate existing erosion concerns through maintenance or rerouting of access roads and trails. At this point we talked about a bit earlier, but even trails or roads that will remain closed will need amendments to prevent erosion. And any trails or roads should have ongoing maintenance plans for the future. And if any mountain bike trails are reopened, if that becomes a priority, consider speaking to a professional trail builder specializing in mountain bike trails to better understand the design considerations for this kind of trail. And if mountain bike trails are not a priority, we would still recommend reaching out to a consultant if you want to design just a hiking or interpretive trail as well. And take special considerations with trail siting in sensitive wild habitat zones, wetland zones, areas of steep slope that are prone to erosion, and within the alluvial fan zone as well. We did identify one suitable area that could have an interpretive loop trail, which may be located north of Thatcher Brook, which encompasses part of the flatter areas of the parcel, is far away from EFUD infrastructure, could provide some viewing of the wetlands and also accessibility to the Tyler Farm cellar.
All right, our second recommendation group is about public outreach. So whether or not you choose to reopen the trails, if they are reopened, it could be engaging for the public to have some sort of interpretive signs. This is an example of a sign at Little River State Park about one of their sort of like hill farms that they have up there. If the trails are reopened, a lot of these foundations are along that main road that's really accessible for people to get to. So it would be easy for people to just sort of see those signs and those foundations without causing too much disturbance, since there's already a road there. And even if the trails aren't reopened, some interpretive signage around sort of educating the public about the landscape and infrastructure and why it's important for their drinking water and why it's important to keep this landscape healthy could sort of move people towards a better understanding of why the trails are closed and how it is important to public health. And so they might be less likely to create those illicit trails if there's more sort of educational signs around why it's closed to begin with. And then sort of along the same line, some interpretive signage about sensitive habitat and why it's important to protect the wildlife and plants and habitat in that area to keep the landscape healthy. And then our second recommendation in this realm is potentially building partnerships with trail builders or mountain biking communities to sort of approach recreation from a place of collaboration that could result in more productive or mutually understood approaches to land management instead of just building illicit trails.
For the plants team, we recommend maintaining and promoting your wildlife habitats and features because they obviously shown by the wildlife team contain a lot of species which are important to the landscape and also to the general health of the landscape. We also recommend reaching out or collaborating with the Vermont Youth Conservation Corps to manually remove the invasive species present because you don't want to use herbicides in controlling for such a habitat because of its resource use. And so you want to engage them so they remove them manually and also replant native species of similar functional traits or bifunctional traits, similar characteristics which would help close the gap which would be open when they are removed. And so that is our second recommendation. We also recommend that you evaluate the potential hazard created by the dead ash trees near the roads and trails of the park, the property, and remove those trees if possible. Also, we recommend maintaining at least 25 to 50% ash trees across your green stands or your forest stands.
And so some recommendations that we have for y'all going forward is the first one is to consider doing more deed research. Our team has noted that it's really complex and time consuming, and so if you're going to go through with this, then hiring a professional would be very helpful. Ongoing engagement with the on-site natural resources, so continuing to engage with this site through seasonal field visits. So you can sort of track and monitor how this land is changing if new invasive species populations are coming up across the parcel, or if you're seeing different signs of erosion or more rogue trail building. Just continuing to keep your eyes on this parcel and these natural resources. Monitor beaver activity is one of our favorites because it's really clear to us how important the role beavers play in shaping wildlife habitat, as well as Michelle mentioned. The beaver wetland is a buffer for potential floods in the future, so keeping an eye on them as long as they're staying within that lower wetland complex area, we think they're doing more good than harm. But if they do, shift upwards and mess around with infrastructure, then you can talk about management with them. And lastly, we
sit those beavers right down.
You can have a meeting with them. Mapping water features. Our team identified numerous amounts of different water features, such as like offshoots of streams and seeps, that we think could be valuable for you as land managers to know about and to have mapped in case you need to turn to those for decision making in the future. And I think with that, that's everything we have for this presentation. Some more photos, and yeah, we'll open up the floor. We have some time for questions. We have about 15 minutes, but maybe we can do a little more time if you have more than a few questions for us. But thanks everyone for being here and for letting us do this work. Yeah, why don't we invite all the students up so we can properly acknowledge the full team.
Take my computer down.
Have a conversation with them.
Have a conversation. Oh, right.
Thanks.
Skip wants me to get a picture.
Okay, so we gotta get in.
All right, all right. Sorry. Oh, wow. Paparazzi.
Bobcat behind him or something.
Sonia, the two of us jump in the room too. I was just being urged out. I think there's a lot of other collaborators in the room too.
Yeah, we'll just turn it.
Josh can pay his tuition.
Great work, you guys. Yeah.
All right, now the E-Fund board joins you.
Okay.
Get out of here. Adelaide, come up there.
Good show.
And our extra class, right?
Now one with Josh in it. Josh, come on. Josh.
Oh my goodness.
Okay, do you?
So one final piece is that we're still working on the final touches of the report. So that will be in your hands or your emails. Imminently, yes.
And the link to this presentation will be provided, as well as all of the maps up. You'll be able to see much more clearly than you did today. So.
I will say the pictures on this computer screen are much better than.
Yeah.
Projectors. Sort of not very thing.
So that picture will be on the front cover of E-Fund's annual report.
Yeah. You send it to us.
So on behalf of E-Fund and the community, we really thank you for all the work you've done, the information that you've provided for a piece of property that we knew was special, but I think you've opened some eyes of how many of our wildlife friends are utilizing it and the importance of it, in maintaining our community. So we really thank you for doing that, and the price was right. So,
are there more questions?
Yeah, I was curious how many, I mean, I know there's so many hours of reading and this and that, but of actually being on site up there? Anybody have a?
At least 3 hours a week, 3 to 4 hours a week, as a whole class. And then Nick lives very close by, so he's there all the time.
Yeah, so I live on Cobb Hill, just outside of town here, and so I did a lot of the natural communities mapping, and so I used it as an opportunity. Every time I needed to go for a walk or just get out, I would go there and go explore a new area. And yeah, I don't know if I want to tell you how much time I spent.
I'm jealous because I haven't been able to.
I have a question for the board. Is it technically true that that parcel really isn't protected in perpetuity?
There's no restriction.
Well, is the parcel protected in perpetuity? As in, for example, what a land trust would do, would get an easement on a piece of land.
Right.
And it's owned, that easement's owned by a third party.
It is not.
Have you considered doing that?
That's all part of the process that we're engaged in now. We'll see. We'll see. Yeah, no, it's absolutely, it's something to think about.
Yeah.
I will say when it snowed, none of them showed up. The second week, when it snowed like 20 inches. I was there.
I was going to say, you were up there.
Were you there?
You should see the van that we're driving.
Our van can no longer pass inspection, and it is being gotten rid of after today.
That's the last time.
I know we keep hearing that.
Or, yeah, at the end of the semester.
might be more than $1,000 next time.
Well, this is a silly question, I guess, but did you feel that this project was valuable for yourselves? Did you learn?
A lot.
Definitely, yeah. Yeah, it's definitely a special place. Like, I really felt that.
I think all the different elements too, like to learn about geology and to be able to see bedrock. And I think it's pretty rare. Like I work in water quality, but on the stormwater end of things. And a lot of like surface water that feeds drinking water comes from, reservoirs, or of course like Lake Champlain. Like 300,000 people drink the water that comes from Lake Champlain. And so the fact that you have this like isolated, forested parcel and you're able to get like stream water, I just think that's really fascinating. And yeah, the connectivity of the wildlife too. So I think like from a learning perspective, like to walk around with Sam too and look at the different like historic foundations and cellars. It's just really interesting and a special parcel for sure.
This is educational.
Yeah, it's a great foundation for us to just keep working on all of this data and information and maintaining the health of this parcel.
Yeah, that's something we talked about, is really hoping that, this product, our final report, kind of becomes like a living document for you all, that you are able to continually go back to and refer to. That informs your work going forward.
Well, and I think to thank the folks before you, the foresters that took care of this land for so long, have done very similar stewardship. So I think it's been, good to see.
People 130 years ago figured we ought to do this.
This is a good boost to the additional, to the information we've had.
And in the whole state, among sort of water systems, it's one of the most pristine there is in Vermont, right?
Yeah. I would believe it.
So pristine, we heard that Stowe had an eye on it, right?
Well, and Stowe has obviously some challenges facing it. So yes, that might be a question as well.
Yeah.
So, in any case, thank you very much.